Determine the slope and deflection at C by the double integration method. E is 200 gigapascals and I equals 500 times 10 to the 6 mm to the fourth. Moment of inertia of ABC is 2I while CDE is just I. Therefore, EI is equal to 100,000 kilonewton meter square, 200 times 500, because we're going to divide this by 1000 to the fourth, so 200 times 10 to the 6 kilopascals, then 500 times 10 to the 6 over 1000 to the fourth, so 100,000 kilonewton meter square EI. Solving for By and Rd, so summation moment about D equals 0. Then we have By times 10 plus 15 times 1 and minus 40 times 6 minus 20 times 12. So By is equal to 46.5 kilonewtons. Likewise, summation moment B equals 0. Counterclockwise positive, so Rd times 10 equals Rd times 10 plus 20 times 2 minus 40 times 4 minus 15 times 11. So Rd is equal to 28.5 kilonewtons. Therefore, we set up moment equation here, the elastic curve for portion ABC. Our x begins with A. So that E times 2I, y double prime ABC is equal to By, which is 46.5 times quantity x minus 2. This is x minus 2 minus 20 times x. So that's the equation. So that this is EI, we divide everything by 2. So EI y double prime ABC equals 23.25 quantity x minus 2 minus 10x. Call that equation 1. Integrating once, EI y prime ABC, 23.25 over 2 is 11.625 quantity x minus 2 square minus 5x square plus C sub 1. So there is C sub 1 because A will surely deflect. The origin A will deflect. Then EIY ABC is equal to 11.625 over 3, that's 3.875, x minus 2 quantity cube minus 5 thirds x cube plus C sub 1x, then there is also C sub 2. Call this equation 3. Then for when x is 2, y is 0 when x is 2. So substitute here. 0 equals, this is 0 minus 5 thirds 2 cube plus C sub 1 times 2 plus C sub 2. So let's set up the first equation. 2C sub 1 plus C sub 2 equals 40 over 3. Call this equation A. And that's the only boundary condition that we can set up at B. Take note that C has same slope as ABC and CDE, same deflection as ABC and CDE because it is a continuous beam. So next, let's set up elastic curve for CDE portion up to E. Actually, you can set up to here, then let's consider RD and 15 instead. In the next slide, we will have an equation which is simpler later. So x begins with A. So I plan to solve that in the next slide so that we will have another way of solving this problem, although the solution is a little bit longer. So EI y double prime CDE is equal to BY 46.5 times quantity x minus 2 plus 28 RD 28.5. This distance is x minus 12 because 2 plus 4 plus 6 is 12, so x minus 12 moment arm. Then minus 20 times x minus 40 times quantity x minus 6. So call that equation 4. Integrating EIY prime CDE is equal to 23.25 x minus 2 square plus 14.25x minus 12 square minus 10x squared minus 20x minus 6 quantity square plus c sub 3. There is c sub 3 because we consider CDE, and all these elements except at D will have deflection and slope, of course. At D, only y is 0. AIY prime integrating is 23.25 over 3 is 7.75. So x minus 2 quantity cube plus 14.25 over 3 is 4.75 x minus 12 cube minus 10 thirds x cube minus 20 over 3 x minus 6 cube plus c sub 3x plus another constant c sub 4. So call this equation 6. Then again, 0 equals 7.75 times 10, boundary condition when x is 12 rather, into this equation yd is 0. So 7.75, this is 12 minus 2, so 10 cube. This is 0 minus 10 thirds 12 cube minus 20 over 3 6 cube. 12 minus 6 is 6 plus c sub 3 times 12 plus c sub 4. So simplifying this equation, we have 12 c sub 3 plus c sub 4 equals negative 550. Call that equation B. Then we now have to equate slope at C, or EIY prime ABC, in particular when x is 6, equals EIY prime CDE when x is 6. So EIY prime ABC equals EIY prime CDE when x is 6. So first here, 11.625 times 4 square, 6 minus 2, 4, minus 5 times 6 square plus c sub 1 equals 23.25 4 square. This is ignored, negative, so minus 10 6 square, 0 plus c sub 3. So c sub 3 minus c sub 1 minus c sub 3 equals, so using the calculator, 23.25 4 square minus 10 6 square plus 5 6 square minus 11.625 4 square, that is 6. Call that equation C. Then EIY ABC when x is 6 is equal to EIY CDE when x is 6. Same common deflection at C. So substitute here at ABC. So 3.875, 6 minus 2 is 4 cube, minus 5 thirds 6 cube, plus c sub 1 times 6, plus c sub 2 equals 7.75 times 4 cube, ignored, minus 10 thirds 6 cube, 0, plus c sub 3 times 6 plus c sub 4. So c sub 1 minus c sub 3 times 6, then plus c sub 2 minus c sub 4, then manipulating this constant, 7.75 4 cube minus 10 thirds 6 cube plus 5 over 6 6 cube minus 3.875 4 cube, that value is negative 112. Because c sub 1 minus c sub 3 is 6 from equation C, if this is 6, 6 times 6, 36. So c sub 2 minus c sub 4 equals negative 112 minus 36. So we can set up another equation, c sub 2 minus c sub 4 equals negative 148. Negative 112 minus 36, minus 6 times 6. Equation D, from here, c sub 2 is c sub 4 minus 148. So substitute this value in equation A. So 2 c sub 1 plus c sub 2, which is c sub 4 minus 148, equals 40 over 3. Simplifying, 2 c sub 1 plus c sub 4 equals 484 over 3. Call that equation E. Then we solve equations B, C, and E simultaneously. The unknowns are C sub 1, C sub 3, and C sub 4 for these three equations. So solving simultaneously equations B, C, and D, B, C, and E, we have C sub 1 equals negative 959 over 15. C sub 3 equals negative 1049 over 15. And C sub 4 is 289.2. So we can now solve theta C into this equation or into this equation, but if we substitute here, there's so many terms, although some of these terms will be zero or ignored. But let's select this equation for theta C. And for delta C, here also, but you can use EI, YC, DE, X is 6 for delta C instead. But we will just use this equation. 11 EI theta C is 11.625 times 4 square, 6 minus 2, minus 5 times 6 square, plus C sub 1, which is negative 959 over 15. So theta C therefore is equal to negative 57.933 over EI. Because EI is 100,000, we divide 100,000. So theta C is equal to negative 57.933 over 100,000. So that would be negative 5.7933 or 793 times 10 to the negative 3 radians, understood radians. Then for delta C here or here, we just substitute it here. Take note that C sub 2 is C sub 4 minus 148 and C sub 4 is 289.2. Into this equation, EI delta C is 3.875 times 4 cube minus 5/3 of 6 cube plus C sub 1, which is negative 959 over 15 times X, which is 6, plus C sub 2, which is quantity C sub 4, 289.2 minus 148. So that's C sub 2. So using your calculator, delta C is equal to negative 354.4 over EI. And since the shortcut to this is you just divide it by 100, 100,000 over 1,000 is 100 to convert that automatic to mm. So therefore, delta C is negative 354.4 over 100 to make that in mm. So delta C in mm is equal to negative 3.544 mm. So that's it for this problem. We'll establish equation for CDE by making this section here. Then we will involve RD and 15 instead on the next slide. So we retain the differential equations for ABC. Then we will have a separate differential equation for CDE, another technique. So this was the established equation for ABC, and we also established this at boundary condition when X is 2. So for CDE, we section it here. So that is X, therefore this distance is 13 minus X. RD was 28.5 kilonewtons. So this is 13 minus X, while this distance is 12 minus X. So remember that moment is positive counterclockwise. So EI, Y double prime CDE, so that's 12 minus X. EI Y double prime CDE equals 28.5 times quantity 12 minus X, then minus 15 times quantity 13 minus X. Then call that equation 4. EI Y prime CDE equals negative, the integral of 12 minus X, because this is negative X, is negative 14.25 12 minus X quantity square. Then positive, because this is 13 minus X again, so positive 7.5, 15 over 2, 13 minus X quantity square, plus C sub 5. Call that equation 5. So EIY CDE equals, so this is positive 14.25 over 3. So 4.75 12 minus x cubed, then this becomes negative again because we are integrating 13 minus x quantity squared, so negative x. So negative 2.5 13 minus x cubed plus c sub 5x plus c sub 6. So take note that I introduce a different constant of integration because we have a different section. Same section, but we consider the forces at the right. Then boundary condition when x is 12, y is 0 in here. So 0 equals, this is 0 minus 2.5, 1 cube. Then c sub 5 times 12 plus c sub 6. So again, this is 0 minus 2.5, 13 minus 12 is 1, positive 1 cube. Then plus c sub 5 times 12 plus c sub 6. So 12 c sub 5 plus c sub 6 equals 2.5. Call that equation F. Then EI y prime ABC equals EI y prime CDE at x is 6. So the slope at C considering ABC is equal to the slope at C considering CDE because that is continuous. So substitute 11.625 times 4 square minus 5 times 6 square plus c sub 1 equals negative 14.25 12 minus 6 is 6 square plus 7.5 7 square plus c sub 5. So establishing c sub 1 minus c sub 5 equation, and that is equal to negative 151.5. Call that equation G. Then EIY ABC is equal to EIY CDE. In other words, same deflection at C considering ABC and CDE because this is the common point. So 3.875 times 4 cube minus 5 thirds times 6 cube plus c sub 1 times 6 plus c sub 2 equals 4.75 times 6 cube minus 2.5 times 7 cube plus c sub 5 times 6 plus c sub 6. So we have 6 times c sub 1 minus c sub 5, then plus c sub 2 minus c sub 6, then computing these terms here, 4.75 6 cube minus 2.57 cube plus 5 thirds 6 cube minus 3.875 4 cube, that will be 280.5. Then since c sub 1 minus c sub 6, c sub 1 minus c sub 5 is negative 151.5 from equation G. So substituting 6 times negative 151.5 plus c sub 2 minus c sub 6 equals 280.5. So therefore c sub 2 minus c sub 6 is 280.5 plus 6 times 151.5, and we establish another equation, call this equation H. Then c sub 2 is c sub 6 plus 1189.5. Let's substitute this in equation A. So in equation A, 2c sub 1 plus c sub 2, which is c sub 6 plus 1189.5 equals 40 over 3. So 2c sub 1 plus c sub 6 therefore is 40 over 3 minus 1189.5, and that's negative 7057 over 6. Call that equation I. Then let's solve simultaneously equations F, G, and I. So the unknowns are c sub 1, c sub 5, and c sub 6. So solving simultaneously F, G, and I, we get c sub 1, which is negative 959 over 15, same as before. Then c sub 5 equals 2627 over 30, and c sub 6 is equal to negative 1048.3 in decimal. So we now solve for theta c. This time we will use equations EI y prime CDE for slope here. Anyway, C sub 5 is 2627 over 30. So EI theta C equals negative 14.25 times 6 square plus 7.5 times 7 square plus C sub 5, which is 2627 over 30. So we expect theta C to be the same. Theta C is negative 57.933 over EI, which is the same as before. So divided by 100,000, so theta C is negative 5.793 times 10 to the negative 3 radians. Or simply do not put the units. Then for EI delta C, let's use CDE equation here. So EI delta C is 4.75 times 6 cube minus 2.5 times 7 cube plus C sub 5, which is 2627 over 30 times 6, then plus C sub 6, which is negative 1048.3. So solving for delta C, we expect the same answer, negative 354.4 over EI. Since the shortcut is we divide by 100, so it's the same. Delta C is negative 3.544 mm. So that's it for the another solution, so that you will experience this solution for the case when the left side has so many forces that it's complicated. So you use the right side, the forces in the right of the section, and counterclockwise positive if you do that.